Hello, welcome to lesson 11-5, area of a rectangle. Our learning goal is to use the standard algorithm and models to find the areas of rectangles with fractional side lengths. Our learning goal for today's lesson are that we are going to use area equals length times width. This is going to be our formula for finding area. Today we're going to look at it with fractional length and width. But you use this to find area of anything. So we'll multiply the fractional length and fractional width to find the area of a rectangle today. You need to make sure to remember to convert improper fractions into mixed numbers if you need to. Always simplify, reduce, or use simplest terms. Those all mean the same thing. We just want to make sure that we get our fractions into the lowest, most simplified form. And we're going to use models to show your understanding. So this is going to use a lot of that same technique that we were looking at in the 11-4 lesson. Please pause and write down your learning goals. Our vocabulary tonight is a little different. Area is the amount of surface a figure covers. So today we're going to be talking about rectangles, but area is just the amount of surface that a figure covers. For example, it's good to talk about the difference between perimeter and area at this time so that we don't get those mixed up. The perimeter would measure the entire length of a fence going around a garden. The area would measure the entire floor space that you're going to cover with carpet. So the area is that internal space. The perimeter is how far around something is. So like a garden, or there was an area you're going to put a fence. Please take a moment and write down your vocab and press play whenever you're ready to move on. For our first example, we want to remember that when you multiply two fractions that are less than 1, the product is going to be smaller than either fraction. And sometimes that is really confusing. We're used to thinking about when we multiply, we're going to get a bigger number. But whenever we multiply fractions, we are actually going to get a smaller number. So here's our example problem we're going to start off with tonight. A park is 3/4 of a mile in length and 2/3 of a mile in width. What is the area of the park? Well, we know that area equals length times width, so we are going to have to multiply 3/4 times 2/3. So this is very similar into what we did during the 11-4 lesson that you did yesterday. So if we take a look at this problem, we have a rectangle, and just like last night, I have already taken my second fraction, and I've looked at what my denominator is, and I have divided this rectangle, or actually I'm going to look at this first fraction. I've divided this rectangle into 3 equal pieces, okay? And so now I'm going to shade in 2 of those 3 pieces. So I'm shading in 1/3, and now I'm shading in 2/3. Now I'm going to change the color here so it makes it a little easier to follow. Let's go to red. And now I'm going to divide my rectangle into 4 equal pieces. So I'm going to try to do the best I can with that. We're going to divide it right down the middle. Divide those right down. Now I know I need to shade in 3 of my 4 equal pieces. So I'm going to do that with the red marker. There's 1/4. 2/4 and 3/4. And I should probably go ahead and write in that the length of this is going to be 3/4. Oh, my 3 disappeared. And this is going to be 2/3. And it looks like I'm looking at this in miles. That's important too, that we have our label. All right, so now the blocks that are colored in both the red and the blue, that's going to be my answer to this problem. So if I count those, that's going to be 1, 2, 3, 4, 5, 6. Out of the total number that it's divided into, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is 6/12. And 6/12 is going to equal 1/2 if I reduce that. So my answer is going to be 1/2 mile. And then now we need to talk about how we label area. When we find area, we find the length and the width, we multiply those together. Length is one dimension, width is another dimension. So we're actually talking about a two-dimensional shape because it's flat. So that means because we're working with length and width, we have to write this as miles squared. Okay, so we're going to put that little 2 right up at the top. We've talked about this a little earlier when we looked at volume, how we always label that as cubed. So when we're looking at area, it is going to always be squared. So area is going to be 1/2 mile squared. All right, so let's go ahead and take a look at our first practice problem. Practice problem number 1, a rug is 4/6 of a yard in length and 1/3 of a yard in width. What is the area of the rug? Well, we know that our formula is area equals length times width. All right, so our length is going to be 4/6 of a yard, and our width is going to be 1/3 of a yard. And I've already divided this into 6 equal pieces. Now I just need to fill in 4 of those. And I got my 6 equal pieces from this denominator. Let's change colors. And now I've got to divide this into 3 equal pieces to show my 1 yard. Do my best. Okay, so now I've got to color in 1 of my 3 equal pieces. So I'm going to do that blue. Now right here, I could go ahead and use standard algorithm, and I could multiply this out. And I should get 4/18. Let's see if my model shows that. My denominator is going to come from how many individual little squares I have here, and that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then I've got to look and see which ones I've colored in with both colors. So the ones that have red and blue both in them, that's 1, 2, 3, 4. So my model is supporting my answer whenever I just multiply numerators and then multiply denominators. So 4/18 is correct, but it's not in simplest terms. I can go ahead and divide and simplify and reduce this by dividing both the 4 and the 8 by 2, and that's going to give me 2/9. But I'm still not done. I still need to label. So my final answer is going to be the area is equal to 2/9 yard, and it's going to be squared. Okay, so let's go ahead and take a look at practice problem number 2. Practice problem 2, a piece of paper is 3/5 feet in length and 2/5 feet in width. What is the area of the piece of paper? Make sure you pause now, try this one on your own, try solving it with the standard algorithm, and then showing your model. Do whichever one first that makes most sense to you, and then press play whenever you're ready to check your work with me. Okay, so right here, I'm going to write my area equals length times width. I have a length of 3/5, and that's feet. And I have a width of 2/5 feet. And I can come over here and just write that in for my standard algorithm, 3/5 times 2/5. And I can go ahead and work that. That's going to give me 6/25. And I know that my answer is going to need to be 6/25 feet. And what else do I need? It needs to be squared because I'm working with 2 dimensions, both length and width. Now let's look at how we'd show that in our model. So I've already taken the denominator of 3/5 and I've divided this whole piece of paper into 5 equal pieces. And I'm going to color in 3 of those to represent that fraction. So 1/5, 2/5, and 3/5. Okay, let's change colors. All right, now I've got to divide my next piece over here. It also needs to be divided into fifths. So let's see if I can go ahead and do that. So let's go try to make it as even as I can. There's 2/5, 3/5, and 4/5. Okay, so now I've got to go through and I've got to take 1/5 and color it in and 2/5 and color it in. So I'm going to do that with my red. 1/5 and 2/5. All right, so my total pieces that I have divided out is going to be my numerator, or my denominator, excuse me. That's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So that's making sense. And then the one that has both colored in, both red and blue, that's going to be my numerator. 1, 2, 3, 4, 5, 6. So my model shows my answer. And the reason that we're doing both is so that we understand how the standard algorithm works. Let's go ahead and look at practice 3. Practice problem 3, solve using standard algorithm and draw a model to support your answer. So this time I'm just going to write in and give you some dimensions. And that's 2/3 inches. And this is going to be 4/5. So go ahead and pause, use standard algorithm and the model to support your answer. Press play when you're ready to go over this with me. All right, so let's go ahead and let's look at this. I'm going to look at this fraction first. I'm going to divide this into 3 equal pieces, or hopefully somewhat equal. And then I'm going to color in 2/3, so 1, 2. Now I'm going to change my color here. Now I'm going to divide this into 5 pieces. One, 2, 3, 4, 5, and I'm going to color in 4 of these. Okay, now I'm going to go down here and use the standard algorithm to see what my answer should be, and I'm going to see if my model shows that. 4/5 times 2/3, so doing length times width, is going to give me 8/15. Let's see how many total blocks I've divided this into, or how many square units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And the square units that have both colors in it is 1, 2, 3, 4, 5, 6, 7, 8. So 8/15 inches squared. All right. Challenge problem. Prairie Point Elementary is located on a piece of land that is 10/12 of an acre in length and 5/8 of an acre in width. What is the area of the land? Use standard algorithm to solve and draw a model to support your answer. Make sure that you do both and show all work. Finishing up, please review your learning goals. Can you solve using both standard algorithm and drawing a model to support your answer? Remember to label the answer to area equals length times width. It's going to be squared, or it's going to have the little 2 above whatever your label is, whether that's feet, inches, miles, meters. Remember to show your work, and we'll see you tomorrow. Nice job.